Hello viewers, today we are going to see a problem, class 12 physics. This is a problem based on a charge moving in a circular path and we have magnetic field, both are perpendicular. That means if the magnetic field is in this direction, the charge is moving like this in a circular path. So this direction and this direction, the angle between magnetic field and the charge that is moving in a circular path is 90 degree. And that circle is having a radius of r. So at each and every point, if you draw a tangent, you will get velocity at each and every point. That means at each and every point, if you make a tangent, the direction of velocity keeps on changing. So these things is the basic thing you have to remember in this problem. So let me read out the question. An electron moving perpendicular to a uniform magnetic field. The magnetic field is given, that is 0.5 Tesla. So this is nothing but B value is given, that is magnetic field is 0.5 Tesla, or other unit is Webers per meter square. Undergoes circular motion of radius 2.1. So the radius is given, which is 2.5 millimeter. What is the speed of electron? So just if you carefully watch, the charge is moving in a circular path. Therefore, there is a force towards the center of the circle. If you look into the mechanical perspective, then it is a centripetal force. And if you work out for the velocity of an electron moving in a uniform magnetic field, so you know that Lorentz force equation. So both can be equated. So you have QVB, charge of the electron, velocity of the electron, magnetic field or magnetic field density can be equate to the centripetal force. So from this V and the square term gets cancelled. You keep this V here, move this R and M other side. So velocity is given by QRB by M. So this you might have studied in chapter 310.2, motion of a charged particle in a uniform magnetic field in your textbook. And this problem has been discussed there itself. So the key concept what you have to remember is the centripetal force can be equated to the Lorentz force equation, which is QVB. We are considering the magnitude, that's why I have written QVB. Okay, right. Now you know the value for charge of the electron. B is given already, radius is given, mass of the electron, all the values we know, just we have to substitute and find out the answer. Okay, so the next step will be velocity is equal to charge of the electron, which is 1.6 into 10 power minus 19 coulomb Q. I am taking the magnitude, forget about the plus or minus, I am taking only the magnitude. Okay, then so we have substituted Q. Radius is given as 2.5 millimeter. So R is given as 2.5 millimeter. So 2.5 milli means 10 power minus 3. So you can convert into meter. And then the last one is magnetic field which is 0.5 Tesla into 0.5 divided by, so we have entered all the numerator terms. This is charge, this is radius of the circle, and B is the magnetic field which is 0.5 Tesla. In the denominator we have mass. So the mass of the electron 9.11 into 10 power minus 31. So we have substituted charge of the electron, radius of the circle, magnetic field, and also in the denominator mass of the electron, or generally charge. Okay. So after simplification, you will be getting the result as velocity is equal to 2.195 into 10 power 8 meters per second. That is, this can be written in standard format as ms power minus 1 meters per second. So this problem has been solved in the book. Hope you have understood the concept, how we are getting the formula, how we are substituting, why we are considering the magnitude, because they have asked only the speed. So direction is not important. So we take the magnitude, and one hint has been given that it's an uniform magnetic field. Okay. So with this idea, I have told you the important point what you have to remember is the Lorentz force equation can be equated to the centripetal force, which is in mechanical domain. This is in electrical domain. So both can be equated because both are force only. We are considering one in mechanical perspective, the other one we are considering in electromagnetic perspective. Hope you have understood this problem. Thanks for watching this video. Nandri.